All right, so because the fact that I just realized that you have an exam this coming Thursday, and I didn't open up the review, it's open now. The treat today is the fact that I'm going to go ahead and answer any questions you have on the review. That is a treat. Trust me, that's a treat. So, questions? What questions do we have on the review? Have we opened the review? Okay. So what kind of questions do we have? You can't have no questions. I guess you could have no questions because everything was so easy. I'm sure of it. Or some of us haven't opened up the review yet. So what questions do we have? Oh, I love it. You're working on it already.
I don't really know what the deal is here. For this X value, it's not imaginary, right?
This is number 3?
Yeah. Because I think I got the right answer. I'm trying to not look at the answers before I'm done.
Yep. So, yeah, that would be your intercepts, right? So intercepts, the x-intercept is when the y is equal to 0. So that means you go set each factor equal to 0. So x squared equal to 0, x is equal to 0. The next one, 0, z to 0. Y-intercept is when the x value is 0. So you just plug in 0 in for everything. But the thing of it is that your first term is x squared, right? So 0 squared, and so that's 0. 0 times anything else is just going to turn into 0. So therefore, your y-intercept would be at 0, 0. And then the other ones would just be.
So is D here, right? Because this one, x plus 3, it would have the minus 3, not a plus 3.
Correct. Yep.
Okay.
Yep. So it'd be 0, negative 3, and positive negative 1.
Yeah.
Perfect. Yep. Nope. Now, if that was x squared plus 1, then it would be imaginary. So you're good. Love it. Any other questions? Giving me a face that you're just going to crap yourself does not help. Ask any questions. When you give me the facial expression of you trying to push one out, does not help anything. Oh, so it's so your crapping and thinking face is the same.
For this, to find these zeros, I could just do the quadratic formula if I wanted to, right?
Yes.
Okay.
Yes. On the exam, we can just graph it. Right? You go, there it is. And don't be confused, because if it only crosses the x-intercept once, and it's supposed to be x squared, right? It's supposed to be 2 times. Well, no. Be surprised. If it's an x squared, be surprised, because if it crosses no times, don't be surprised, because it could be imaginary. And don't forget this too, right? Because the reason why I say if it's squared, if it's imaginary, it has to be a pair, right? Imaginary is all conjugate pairs. So that's why if it's squared, if there's 1, there's got to be the other x-intercept. It can't be 1 real and 1 imaginary. The imaginary has to be a conjugate pair. So it has to be pairs. Okay. Anything else? Yes? Yeah, that's what I'm saying. I will answer any questions on the review. 4. You know, again, it's all my fault, so I'm gonna take responsibility. All right, so 4 says 3x to the third minus 19x squared plus 30x minus 8 equals 0. And it wants me to find the real solutions. So if I'm finding the real solution, I'm really looking for what? Huh? The zeros, the x-intercepts, because it's set equal to 0. So that means telling me my y value is 0, right? So the way I'm supposed to do this, if it was lab work, then I would throw in Desmos, this equation, x to the third, 3x to the third. Wow. Minus 19x squared plus 30x minus 8, right? So this is a bad example because I'm supposed to be able to find 1 given the graph, right? And then from there, I'm supposed to do my long division. That would be a lab work. But here, I see my 1, my 2, my 3. So my solution would be 1/3, 2, and 4. Make sense? Do you want me to do it the right way? The right way would be saying this. I have an x-intercept at 2, which means that one of my factors here is going to be x minus 2. So I'll do x minus 2 and do my long division. X goes into 3x to the third would be what? 3x squared. Multiply would give me a 3x to the third minus 6x squared. Flip the signs and add. Negative 13x squared plus 30x. Negative 13x times gives me what? Plus 26x. Flip the signs, add. Then I got to factor this. Yes? Do you guys remember the rule? How to find real zeros if we were not given the chance of using Desmos? Meaning, back in my day, back when back in the caves, before Abacus, we would have to take the factors of the constant, divided by the factors of the leading coefficient. So we'll have to do 1 over 1, 1 over 3, 2 over 1, 2 over 3, 4 over 1, 4 over 3, 8 over 1, 8 over 3, and plus and minus on all of those. Remember those notes? And then we'll have to try it, right? So, but we were saying because of calculators these days, let's give them one with a graph, and then they can do the long division for the others. Okay. So as you guys can see here, this gives me the 2, this gives me the 1/3, and this gives me the 4. Okay. Next question. Someone had their hand raised over here. Did I see a hand raised? Was there a question? Go for it. Number 12? You throw it out. No. 12 says f of x is equal to say, why can't you factor the bottom? Well, let's do the AC method, right? All right, so let's go Cuban style. Cuban style meaning that what they do is they do A times C on top. So if I did A times C, I get what, negative 14? And then they put B on the bottom, which is negative 5. Two numbers multiply together to give you negative 14, but added together to give you negative 5. You're going to tell me it is? Does that make sense? Okay. So that means what I'm going to do is I'm going to split the middle term. So I got 2x squared minus 7x plus 2x minus 7. I could have used the plus 2 first. It doesn't really matter. So I split. GCF of the first group is, leave me with, wow, you guys are so quick. GCF of the second group is, leave me with, so I can factor it. Son of a gun. By golly, J, I do have it. So that's going to be 2x minus 7 and x plus 1. How did you get through college algebra without knowing how to factor? Who did you have? Who did you have for an intermediate? Lord, give me strength. It's not your fault. It's not your fault. Because this, in other words, when A is not equal to 1. When A is not equal to 1, those are the ones that are the most important part, right? Like for me, I with my intermediate algebra, it almost sounds threatening to them when I talk to them. I just had that conversation with them today. I'm going to have it again at 2 p.m. as well. It's going to just sound like I'm threatening them and their life if they don't get this thing down. So, but the other thing you can do is trial and error.
Yeah, that's what I usually do when I figure it out.
Okay, so, but here's the thing. If you did trial and error, right, you know that the first terms are going to give you the 2x squares. So this times this has to give you the 2x squared. Okay? So that's a prime, easy. Right? It has to be 2 and 1. These last two terms has to give you the negative 7. That's easy as well. The only difference is I know it's 7 and 1 because it's prime. Correct, which is positive and negative. So you got to try it. So this is where the OI comes into play. So let's say we did negative 1, positive 7, right? My outer would give me a positive 14, right, if this was positive 7. If this is negative 1, the inner would give me negative 1. Does 14 and negative 1 give me negative 5? The answer is no, so that's when you switch things up, right? So you're going to have to check your OI. So if that is your saving grace right now to make sure that you know how to factor, so be it, right? It's almost like you guys don't have the time to really practice enough AC method to get through anywhere. So you're just going to have to say, I'm going to grind it out with trial and error. Yeah. All right? The issue that you're going to have is when the 2 is not prime or the 7 is not prime. Then you're going to have to really try different things. It'll be interesting to see what you guys put in on what we know. 19.
I have a quick question on number 5.
Okay.
I just want to know, am I supposed to divide? Because it says f of x has a factor of x plus 1. Do I divide or do I plug in?
Yes, you should do a long division.
Okay. Thank you.
Mm-hmm. Well, I mean, you know what? On the exam, how would you do it on the exam? If this was, well, this will be a problem in the exam. If it was on the exam, how would you use the choices to help you? Huh? Plug them in. And see which one has a factor of, or has a solution of negative 1. So I'm going to have to do this one for, and I got some beef with you guys about your lab work. I know I didn't grade it, but I looked at some and I'm like, what the? So we'll talk about that. Okay, here's number 19. This is to decide which of the rational functions might have this graph. Okay, so we know vertical asymptotes, yes? Where are they located?
Well, x equals -2 and x equals 3.
So that means, now, where would vertical asymptote be at if I have, well, sorry, this denominator? So that means this is going to be x plus 2 and x minus 3. Are they going to be even or odd? How do I know if they're even or odd?
The multiplicity?
Yes, but how do I know what the multiplicity is for these two vertical asymptotes? How do I know if it's even multiplicity or odd multiplicity? It has something to do with this and this. It can never cross a vertical asymptote, right? Because that's why it's in the denominator, because if there was a value for -2, right, then it'd be undefined. Uh-oh. Beautiful. If going towards the vertical asymptote, they're going in opposite directions, those are odd. If it goes in the same direction, those are even. And those are also in the notes. I know, shocking. All right? So we know that those are going to be odd. So how do I find a numerator for this? The solution, the zeros. So the numerator is going to be the zeros. And what's my zero? Is that, well, how do I know if that's going to be an even or odd multiplicity? If it crosses or bounces. Oh, we remember that one. But we don't remember about the vertical asymptote. Okay, done. No, they're not. Okay, so so think about it this way. Just like word problems. If you think about math word problems, it's a bunch of distractions around specific information you need. Is that true? You just got to extract that information out, and that's it. Everything else is just busy words. Just to, like, say, hey, look over here. Right? Same thing with this. Right? I'm trying to find this equation. Everything plays a part, but it's still a distraction. If I just focus on denominator, vertical asymptote, got it. Odd or even, got it. What's the behavior around that? Right? Numerator, zeros, got it. Where's my zero? Odd or even, the behavior around that. So really I'm only looking at this point here, and then these end parts. That's it. The rest is just a distraction. So just focus on what is necessary for what you need and be done. Right? While you guys are looking up questions, I'm going to pull up lab work 5 here in front of me so I can actually say my piece with you so that I won't see this anywhere else. I was supposed to grade number 2, which is about the horizontal asymptote. Do you guys remember that? Okay. So here's my question. To find a horizontal asymptote, what do we do first? To find a horizontal asymptote, what do we do first? Go ahead. Factor. Okay, factor top and bottom. Okay. Do we need the factor? No. We actually don't need a factor. What is the first thing we got to look for? And what was the words I used? The highest powered term on top versus the highest power term on the bottom, right? We only care about those two terms, right? The strongest man in the north, or man or woman, versus the strongest man or woman in the south, right? They're going to battle it out on who wins, right? Remember that example? This way nobody else has to die. It's only one person dying. That's it, right? So that's all we needed. Highest power term on the top versus the highest power term on the bottom. And then we had 3 cases, yes? If the power on top was bigger, power on the bottom was bigger, or if the powers were the same. So again, this to everyone. Remember what I said. And I see here Dominic actually did all 3 cases. You guys in the what we know is about the general information, yes? What I'm supposed to be able to do is cut the what we know and place it to a similar problem and get the right answer. So I should write down those three cases in the what we know. Does that make sense? Is that fair to say? Okay? So highest power term on top, highest power term on the bottom. Here are my three cases. In the what we know should have nothing about the problem in it. So I should not see x to the first x squared or 3 or the 6n or 6 whatever, right? I shouldn't see any of that in the what we know. Is that fair? Okay? But I really only need to know that those two things, right? Take the large power term top, large power term on the bottom. Done. Here are the three rules. Here are the three scenarios. That's it. Right? This way on the left side, as you're showing the work, you're like, we're focusing on these two terms. Since the power on the bottom is larger, therefore the horizontal asymptote is y equals 0. Done. So that should be the things I should have saw on your what we know. Is that fair? And then the work on the left-hand side. And so like here, no, they didn't write down largest power term on the top versus largest power term on the bottom. This one we still need to talk about how to scan because it is really, really big. Who's it that I saw that I was like, I gotta close this? Where is it? Oh, it wasn't here. It was. People are still writing on the other side of the paper, and it's definitely leaking through, especially when you're writing in pen. So like this one right here on the left side says 1 less than 2, y equals 0. How am I supposed to know what the heck you're talking about? Is that fair? The what we know is pretty good. Oh, did this show up? Oh, it is in here. It is in here. So the what we know for number 2, which is the horizontal asymptote, okay, which is for the horizontal asymptote. Here's the what we know. Factor top and bottom. Find holes. Does finding hole has anything to do with horizontal asymptotes? No. Did we need a factor top and bottom? No. Right? And here's the scary part. Their work, they factored, and then they arrowed and saying x on top and then x squared on the bottom. And it says horizontal asymptote equals is at y equals 0. So you factored, and then said the bottom's largest power term is x squared. Does that make sense? Right? So I want you guys to understand that. Okay? And however they scanned it, I only see about this part of the paper. Apparently, you guys are trying to conserve paper as well. So I see work, what we know, and then problem number 3 is like using the other half of the what we know. Guys, if you need paper, I got you. There you go. If you need more paper, I got you. I got you. There's a reason why I tell you to write on the one side of the paper, right? The what we know should be with the problem. And whichever one ends lowest, start the next problem there. Make sense? Okay? But I got you. You need more paper? I got you. All right? Apparently this person here was trying to conserve pencil because I can't read it. It's written that light. Ladies and gentlemen, just so you know, I am a half a century old. Eyes are going. And I don't think my reading glasses will help any of this very light gray writing. Find domain all possible x values. But again, that's my 2 cents about the lab work. Yes?
I didn't get it in on time, and I emailed you, but did you look at it just to check it out? Or?
If you didn't get it in, I did not check it out. Sorry. I'll look at it right now if you want me to.
Can I ask what did you look at?
That's great. The only thing I would add on here, largest power term on top versus largest power term on the bottom. Other than that, great. Okay?
I also did it for some reason.
Did you try to do it through an app?
I have not. I don't even remember, but I
Okay.
did the whole thing.
If you did it through the app, I would tell you that's only gonna work like 70% of the time.
So I should go through notes?
I would go through Canvas.
Okay.
Yeah. So same thing. Largest power term on the top versus largest power term on the bottom, right? Just focus on those two. And then give me all 3 cases.
Okay.
Okay, especially in the what we know. I think the 3 cases will help because then if I was to put the what we know into another horizontal asymptote problem, they can use those notes and get the right answer because all 3 cases are there. So whatever happens on the left side, they can go, oh, wait, largest power term on top versus okay, let's look at what the largest power term is. Great. Next, here's my 3 cases. What case do I have? Great. Done.
Is this too big? I remember we talked about the scanning, and I used a new thing to scan this time.
When you are in Canvas and you click on it, does it show you the whole thing? So when you go to your grades,
Yeah, I went through grades, but it just showed me the submission and made me download it like that.
click on the left, click Lab Work 5. Click the left thing. Oh, it did do that to you. Interesting.
So here it doesn't look huge, but I don't know.
No, I think you're going to be fine. I think that's going to look fine. All right, let's go back to the review. Any other questions on the review? Enough talk about that lab work. Let's just make it better. Make it more gooder. Did you guys get the rubric as well in your Canvas inbox? Was there anything to add or subtract from it which looked like this? You guys remember that? I sent this to you guys as a PDF through Canvas inbox. Does this cover everything that we're talking about here? Now notice that general has an asterisk on it, so it's down here as a definition. General means the steps and methods that you would use to explain to someone else about a similar problem. Information about the problem should not be in this section. So obviously this is the right side. This is the left side, right? This is just that you can do f of 3 is, and be able to plug that in and get it right versus getting it wrong. And then your quality of scans, not right on two sides and stuff like that. If you guys look it over and something's missing, let me know. If not, I'm going to probably start using this rubric as a grading to give you guys your points. And whatever comes out from there. No questions. Okay, let's go back to the review. Any other review questions? Nothing?
Hello.
Hello.
I have a question about the lab work. In the part that we show our work, should we just show our work or explain every step two of the problem?
On the left side?
On the right side. The left side, yeah, left.
The left side you should show your work, yes.
So we don't explain like every step.
I think it depends on the problem. Like for example, here, let me bring up that. That's in number 2, right? So all depends on the problem itself, right? That I might have to do some explanation on the left side.
Okay, yeah, because with problem 2, I only identified the powers and just like, okay, so like the top and the top is less than the bottom one, so y equals 2.
Yep. So because here's the thing, if I was to write you a note, right, and I just did this. Let's say I just did this, right? Or class, you know, you got x squared on the bottom, so horizontal asymptote is that y equals 0, right? You would have a lot of questions for me. Like, why that term, and how is it y equals 0? Right? So that's why I would say, okay, so we might need to kind of, that's the reason why we would need to kind of have all of this to kind of explain that part in terms of work, right? So it all depends on the problem, and sometimes it's explaining it with words, and sometimes it's just showing the work itself. Okay? All right. Any other questions on lab work or the exam? Yes? Nope. There was no notes on number 5. Number 5 is saying, let's think outside the box. So let's go back to number 5. So number 5, you had f of x equals to x to the 4th plus kx to the 3rd plus 2. And it says has a factor of x plus 1. Right? So what I know is that I can do long division. Because it's telling me it's the factors, right? So let's take this. How many times does this go into this? Awesome. Multiply. This is where your patience is going to come into play. Okay? Does that make sense so far? What is it going to be? Right? If I multiply that, I'll get oh boy. Oh, not gonna like this one. I got nothing else to bring down. Go ahead. We could do that too. I see what you're saying too. That would be easier actually. Because you're talking about the remainder theorem. Yeah. This part? Are you talking about this part? So question is, how many times does x go into this? So in other words, this times what would give you this? But what she said is very true. Go ahead.
But how do you go from kx to the 3rd plus x, or minus x to the 3rd, to that, to k minus 1, x to the 3rd?
Because after I write this, I have to multiply this, right?
Yeah, but I'm saying from the first step, when you minus the terms, right?
How did I get this?
Right, exactly.
Okay. So if I was to write this, kx to the 3rd minus x to the 3rd, what's my GCF? What do I have left?
K minus 1.
I like her thought process, though. She threw me in the loop right there.
What did she mean by that then? Just plug in minus 1 for the entire
Where was it? Where was it?
That's a really ugly equation.
Huh?
With the case, that's a really ugly equation.
It is. It is. So what she was, I wanted to bring up the notes. Where's the notes? When was the notes for that? Dang it. When was the notes for that? When was the notes for that? We did it. I can't remember when the notes were. For like the remainder theorem and you know what I'm talking about? It was the remainder theorem and the factor theorem. Ah, this is peeing me off now. That's what she's talking about. Remember that? Because what we know is that if we throw in that factor that we had, which is the x plus 1, right? Like I even forgot it. So thank you for reminding me. So I put negative 1 in. I know that the remainder should become 0. Okay? So what she's saying is, I'll come back to this again, but what she's saying is, if I use, let me just use the whole thing. That's what she's saying. But what I also know is that this is supposed to give me 0 because I know that this is, I'm given that this is a factor. So what I have here is that negative 1 to the 4th would be positive 1 minus k plus 2 has to equal to 0. It is way easier.
It's weird because like I was trying to just plug one in and I picked the right answer for it.
Yeah, if you were to plug it in, what you can do is just graph it and see which one gives you a 0 of negative 1. Right? So you can just plug in negative 2, plug in the 2, plug in the 3, plug in negative 3. One of them is going to give you 0 of negative 1. Was it? Was it? Let's see. It was x to the 4th. Let's choose plus 2x plus 2. Oh, wait. X to the 3rd. So that right there tells me that that can't be because it's all imaginary. So we had negative 2 minus 2. That didn't work. Plus 3. That has negative 1 right there. And then, what's the other? Minus 3? Then that has a positive 1, so that should be x minus 1. Make sense? Oh, the TI might look different too on your. Yeah, let's not do it my way. That one you probably do need the placeholders to get there. Because I'm going to guess you're still going to get into the negative k plus 3 by the time you get there. Next question.
I have a question about solvent product.
Okay.
A different way. I remember being taught that you could look at the signs in between the terms to determine if your factors were positive or negative. Can you do that?
If it was an x squared, yes.
It doesn't work with polynomials, it's only quadratics.
Yeah.
I wasn't sure.
I don't think it would work for polynomials. Because there's so many it could be so many terms, right? So essentially this could essentially be 5 terms. And then the symbols in between doesn't really correlate very well. But if it was just the 3 terms, then yes, right? Because it's like A times C has to be positive, so those two numbers multiplied together, if the B is negative, then those two numbers would have to be negative, which makes sense. Anything else? Nothing else? Clear, you have no questions. And it's okay.
It's because I thought the test was today, so I studied all last night, all this morning, thinking the test was today.
You know it's listed, right? It's written down.
Huh?
You know.
I don't know, I just thought it was today. I studied all last night, went to sleep so late studying, which is good, because now I don't have to study. Like, before I just keep studying and just,
But you know that it is
I know, I saw it.
right here. It's listed right there. I mean, it's not even listed just in week 6. It was listed in 4 and 5 and 6. It is okay though, right?
It looks complicated at first.
23.
Seems like there might be stuff someone familiar with.
Let's see. Okay. But what's the first rule with inequalities? Move it so that it's equal to 0. Right? You could. No, you can do the quadratic formula. Just remember that when you do the quadratic formula, you have your 2 zeros, right? Then you got to pick numbers here, here, and here to see what's positive, what's negative. And then based on that, since this is saying greater than 0, that means I'm looking for positive. So that will give me, so if it was, like, say, positive, negative, positive, then I know that I want this and this. Right? Make sense? And if it was negative, positive, negative, then I know I'm going from here to here. Right? So that's the only thing. Would that work? Or, heck, let's find the answer right now. It was 36x squared minus 36x. No. I keep on saying minus 65x minus 36, right? Okay. Less than 0. If it was equal to 0, then we're looking at zeros, x-intercepts, right? But we're looking at less than 0. So if you look at the graph, where's less than 0? So it must be from here to here. Make sense? So that means I would have had plus, whoa, sorry, my bad. It's not looking for less than 0, it's looking for greater than 0. So greater than 0 is above it, right? I'm like, we want positive. So this plus minus plus, so that means whatever this 0 is to infinity, and whatever this 0 is to negative infinity. Okay? It's really interesting to me that they use the word or. That should be the word and, because the solution is here and here. Yeah, it's any. So the or is used because you're right. It is any solutions here or any solutions here. But the word union is usually everything is included. Where the intersect, oh, you know what? You're right. Nope. Or would be the union. Because the intersect is what's in common. So it would be and. That would make sense. Yep. So or would be the union. So it's A. Anything else?
For number 6,
Mm-hmm.
we're trying to get the other roots from the imaginary roots. I know we can get the conjugate of 2 plus 3i, but I
Mm-hmm.
don't know how to write that as a factor.
Okay. So if you have 2 plus 3i, right, as a 0, because its conjugate would be this, yes? Okay. So remember completing the squares? So completing the squares is where, remember when we took the square root of both sides, we had the plus and minus. Right? And then to get the answer, we'll bring that constant over to the other side and then plus or minus square root of whatever. Just like the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, right? So same idea. So before we did that, we would move it back over to the other side, so we would just do this. How do we get rid of I? What's 3i squared give me? No, no, no. Oh, shoot, I forgot. This is supposed to be x, not 0. That's what it's supposed to be. Does that make sense? We're not done yet. Does the negative 9 make sense, though? Okay. Yes, because positive squared is positive. Negative squared is also positive. So there's that part. And then you just do the long division from there. Right? That makes sense? Okay. So you don't remember completing the square?
I know I've done it, it's just I keep, and I've like brushed up on it like a week ago. I've looked it up like 5 times. I keep forgetting it.
So let's keep it simple. We'll keep it very simple. Let's say x squared minus 10x plus 2, because at least I know that that's not factorable, right? So completing the square is equal to 0, let's say, okay? So completing the square is where you got to make sure that a is equal to 1, okay? Then you would essentially move the OC to the other side. And then you want to find a new c, right? So c is equal to b divided by 2 squared. And in this case, negative 10 divided by 2 squared, which is equal to negative 5 squared, which is equal to 25, right? So you add 25 to both sides. And then what you would do is you'll factor the left side and add or subtract the right side. So when I factor the left side, check this out. So this right here, when you do the work, always helps you factor this, right? So from here is where I'll use the square root property. So here's where I would take the square root of both sides, because I got to get rid of the squared. So I take the square root of this side, which means I take the square root of this side. Sorry, Jordan. Hopefully people understood what the heck I just said. Plus or minus, right? So the left side is now going to be x minus 5 is equal to this right here. Oops, not what I want to do. Right? So what do I do now? I move the 5 over to the other side. So now I have x is equal to 5 plus or minus the square root of 23, right? And that's what I meant by over here, if you remember what we did beforehand. So we went from this step to this step. So that's why we had to move the 5 over, just like we moved the 2 over.
That makes sense.
Okay?
Once I see it.
So that's why I wanted to show you this, is so that you guys can see. My goal is just to move it over to the other side, square both sides, right? Because I want to get rid of the plus and minus. And in this case, I, right? And then I can square and then I can FOIL this out and then move that number over, and that will be my polynomial that I need to use for long division to get the other part. Okay, doke? Do you need further, or that is all you needed?
No, that makes more sense.
Okay, okay. Any other problems? Nothing else? Go ahead. Ask your question, dude. It's all good. Okay. Anybody have any hints? Absolutely. Well, let's get it one fraction. Was the 1 missing? If I do that to the bottom, I got to do it to the top. Are the denominators the same? Okay. How does that help me? Do I have a vertical asymptote? Yes? Where is it at? 0. X equals 0. Do I have a horizontal asymptote? No. Do I have a oblique or slant asymptote? What is that? Huh? Long division, and what is that going to give me? Y is equals X. Right? All right? So out of those two equations, out of all of that, I can now take out 2 graphs. A is gone, C is gone. Is that true? Left with B and D. How do I differentiate if it's B or D? How do I know if it's B or D? How can I tell?
You could plug in a value for the graph.
Plug a point. Look at when x equals 1. Is it pretty different between the two graphs? Yeah? Okay, plug in 1. What do we get? 1 squared plus 4 is 5 over 1. So which of those graphs has 1 comma 5? Okay. There's your answer. Man, I'm good. Right? But again, this gives me my asymptotes, right? 2 out of 3. Right? Because I can only have oblique or horizontal. I can't have both. I can have one, the other, or none. All right? You're either getting the burger, the fries, or nothing at all. You're either getting the broccoli or the cauliflower, or no dessert at all. Any other questions? Do we feel confident on this exam? Well, that's good news. 22.
Asking about a graph, whether or not it includes 0, and it looks like there's a horizontal asymptote at 0. How can we tell if it crosses or includes it just from the graph?
I would say it includes it for sure. Because so a graph can still cross a horizontal asymptote and can cross an oblique asymptote, right? And 22 is less than or equal to 0, so I would say it still includes it as anyways, because it has to. I mean, it usually it doesn't go and then keeps on going that way. The only time that would occur is if there was supposed to be a vertical asymptote there and there's a hole ends up being there. That's the only time that would happen. So, does that answer your question?
Yeah.
Okay.
But we can't really tell that just from looking at a graph like that, so how do we do that?
Yeah, I mean, unless the equation that was given. So, if there was supposed to be a hole at 0, at 0, 0 in this case, then they would have to provide an equation where it shows that at 0, it would cancel out, so there would be a hole there. That would be the only way that it would show that. Does that make sense? So it'd be like x parentheses x plus 1 over x. So you know the x cancels, and that's the vertical asymptote. Well, I guess there's the other 2 with vertical asymptotes. So, but that would show that would be where an open hole would be. Okay? Anything else? Just come in wherever there is a desk with an exam on it and it's empty, just sit there. And I'll meet you there. Okay? And I don't want you just not to fail the test. I want you to ace the test. Okay? You guys have made a promise to yourself after exam 1 of what you guys need to do to make that happen. And I know that you guys are supposed to be mature enough to make that happen. Yes, I'm looking at you. Right? So I know that you will make those changes. Now, I will tell you this as well. I think that you guys should reach out to each other to try to get some more practice in. And I think that I know that MLM can kind of go a little crazy, but I really wonder if you were to take this PDF, download it to your phone, and feed it into ChatGPT and say, can you give me 5 more problems of number 17, if it could do that, right? So instead of going to MLM to try to find a problem and then view similar problems, I wonder if that would help. And when you do that type of problem and you're wondering what the answer is or if Chad is right, feel free to send me the work and the problem, and I don't mind checking it out to say yes, no. That make sense? Okay. So you guys have got a couple more days to make that happen. And if you have any other questions, just let me know. Fair? All right. So no other questions then? We'll call it a day. All right, ladies and go ahead.
I have one more.
Yep.
On the lab work,
Yep.
I think it was, I wrote down the front,
Lab work 6.
yeah, lab work 6B.
Uh-huh.
Where is it? For the first problem,
Yep.
factoring the top, where it's the negative x squared plus 16,
Mm-hmm.
I factored it as negative x plus 4 and then x plus 4, but then I checked it because I wasn't sure, and I checked it with like an online ChatGPT thing, and it factored it with the negative in front of the parentheses, and then I tried to, so it was negative x in front of the parentheses of x plus 4, and then in another set of parentheses x minus 4, and then I did it that way, and I got the wrong answer.
You shouldn't get the wrong answer because for the vertical asymptote, it's only the denominator that matters. Right? But here's what I would probably have done. I would probably rewrote that top problem, or the top polynomial as 16 minus x squared.
16 minus x squared?
Because if you look at this, if I was to rewrite this, couldn't I rewrite this as 16 minus x squared? Isn't that the same thing? So in that case, how you factor was correct. 4 plus x, 4 minus x. But what they said was right too. Because if I pull the negative 1 out, I will have now x squared minus 16. So it would be negative 1, x plus 4, x minus 4. But that should not sway you to a wrong answer because this is asking for vertical asymptote. So it really all depends on that. The only I see why it would make you get the wrong answer. Gotcha. Gotcha. Because this is going to factor to what? X plus 4, x plus 1. So since these two cancel out, that's where the hole is going to be. So the only place that's going to have a vertical asymptote is here.
Yeah, and I got that in the end, but when I did it the other way and I had the negative in front, I distributed it before I canceled my factor.
Duh.
And I thought that nothing canceled.
Yep.
And then I checked it.
That's why. Okay.
I went back and did it with the first time, and I went, wait a minute, they don't cancel.
Mm-hmm.
But it does.
They do cancel. Yep. Yep. So they do cancel. So either way you do it, if you want to factor out the negative 1, that's certainly fine. Just don't put it back in. Leave it out. Just like if it was a GCF. Or just switch it, because this is still x plus 4, no matter how you look at it.
That's where it went off.
Yep. Haha. Haha. So, remember that the optional lab work is a review for what? Huh? The final exam. So I had to take those 40 questions and kind of try to squeeze it into 4 different lab works, right? So instead of having one lab work being 5 and the other lab work being 15 problems, I had to throw problems in like this, right? So yes, logarithms was from college algebra. You do remember? Oh no. Lordy, lordy, lordy. Oh, I do. And that was exactly the end of college algebra, right? All right, so if you go to, so any of the videos that are linked, that are like pre-recorded stuff, if you click YouTube, you'll get to this channel. Hit playlists, and then go to the college algebra. And then it's going to be towards the end. So 18, 19. Is that what's going to help them? Let me look at lab work 6 really quick from here. And let me pull out. I do want to make sure it helps you guys as well here. Lab work 6B. You said 6 and no. 8 and 10. 8 is using the log form. B, let me make sure here, guys. That's going to be towards the end. Come on. I just want to make sure 17 is not necessary. 18, 19, 18, yes, for sure. I don't even know if 19 is necessary. Hold on, let me erase all this first. And then what I was going to do was go to college algebra. Because for some reason my computer is taking its sweet, sweet time. Now, is that going to help? So 4.2. Yep. So this part right here, the very first part, is going to help. So just the first part there. Okay, let me try this again. How about now? All right, let's go there. Four 4.3. None of that is needed. That's definitely not it. Let's go back to 4. So 4.2 only. So 4.2 should help, guys. Look at that lab work again. Yeah, 4.2 should be all you need, which is number 18 in college algebra. Should be the only thing you need for 8 and 10. Does that help?
Yes.
Okay. All right, ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. I'll see you guys on Thursday for the exam. Yay!
So Shannon, I know I showed you this, but I obviously didn't have a chance to submit it because it just didn't work. So should I email to you or?
Don't worry about it. Do the optional lab work to take care of it.
Okay.
So for the test on Thursday,
Mm-hmm.
I'll be I have the final
I'll send it over. I'll take care of it.
I have a question on number 7.
What about it?
So the first step is you would have to get the zeros right.
Yep. So get the zeros.